Welcome. In today's tutorial, we are going to discuss about the derivatives of logarithm functions. So to find the derivative of logarithm functions, we need to know the inverse functions and how to find the derivative of inverse function. So let f is a function from set of real number to real number, and g is another function from set of real number to real number. Now if f composition g x, which is equal g composition f x, is equal x, then f and g are inverse to each other, and so g of x is equal square root of x. Then f composition g x, which is equal f of gx, is equal f of square root of x. G composition fx, which is equal g of fx, is equal g x square is equal square root of x square is equal x. So therefore f and g are inverse to each other. Notation we use for the inverse function denoted as f inverse. So this is inverse of f. So d dx f inverse x. So this is equal 1 over f dash f inverse x. Let's have f inverse x is equal square root of x. F of x is equal x square. Know that d dx of square root of x is equal 1 over 2 square root of x. But we will try to find this derivative using this formula. So here d dx of f inverse x, which is equal d dx of square root of x, this is equal 1 over f dash square root of x. Now we have f of x is equal x square, so therefore f dash x is equal to square root of x will be 2 square root of x, so this will be 1 over 2 square root of x. So therefore using this formula we can find the derivative of the inverse functions if you know the original function f. Next is the what is the inverse function of e to the power x and ln x, and find the derivative of ln x. So let f of x is equal e to the power x and g of x is equal ln x. F composition gx is equal f of g e to the power gx, so e to the power ln x, which is equal x. Same way g composition fx is equal g of f of x, which is ln f of x, is equal ln e to the power x is equal x. So this implies ln x is the inverse of e to the power x. So we can write now f inverse x is so now to find the derivative of ln x, so we have d dx of ln x, which is equal 1 over f dash ln x. F is e to the power x, so f dash x is also e to the power x. So we have here 1 over e to the power ln x, which is equal 1 over x. So therefore derivative of ln x is 1 over x. And if you have to generalize this, so d dx of ln hx, any function h, then this will be 1 over hx, and then derivative of hx by chain rule. Question is that find y dash x from y is equal ln x. So here we will write the recall the formula for this. So d dx of ln hx is equal 1 over hx derivative of hx. So how we can do it now? So solution here, dy dx is equal d dx of ln x plus 1. So x plus 1 is hx here. So we'll have whatever inside of the ln x plus 1, and then derivative of x plus 1. So which will be, this derivative is 1. So we'll have here 1 over x plus 1. Done. From y equal ln x. So here we have dy dx is equal d dx of ln sin x. So ln sin x, so inside function is sin x, and then derivative of sin x, which is cosine x. So you have here cosine x over sin x is equal cotan x. Find y dash x from y equal ln e to the power x square plus ln tan 2x. So before solving this, we will do little simplification. So we can write y is equal ln e to the power x square plus ln tan 2x. We can apply the chain rule on the ln, but before that we will see there is some simplification, and this simplification is given as this will be x square plus ln tan 2x. This is done by the formula is identity ln e to the power f of x is equal f of x. So therefore dy dx is equal to x plus, for ln it will be 1 over tan 2x, and then derivative of tan 2x. So this is equal to 2x plus 1 over tan 2x, and tan 2x derivative will be secant square, and 2x derivative of 2x. So this is equal, tan 2x is 2, so we'll have 2x plus 2 secant square 2x over tan 2x. If further simplification is not needed, you can stop here, but You may, if you want, you can simplify with this formula. Secant square 2x is equal 1 plus tan square 2x. So therefore we will get it here 2x plus 2 over tan 2x plus 2 tan 2x, which this can be written as 2 over 2 cot 2x. Next we have some implicit function involving ln, so we'll try to find the solution here. So ln y square is equal ln x to the power 4 plus y, which can simply written as 2 ln y is equal 4 tan x plus y. Now take the derivative. We'll have derivative on both sides. D dx of tan y is equal 4 d dx of tan x plus dy dx. So this implies 2 1 over y dy dx is equal 4 over x plus dy dx. So this implies 2 over y minus 1 dy dx is equal 4 over x. Dy dx is equal 4y over x and 2 minus y. Yeah, find y dash x from y is equal this complicated product and division. So how to solve this problem? We'll follow step by step, and this solution might be little bit longer, but it's easy solution. Apply ln on both sides. So ln y is equal ln x plus 3 sine x plus 2 e to the power 3x over x plus 5 to the power 3 x square plus 3. So now we'll use the ln property, and we'll see that here this will can be written as ln x plus 3 plus ln sine x plus 2 plus ln e to the power 3x minus ln x plus 5 to the power 3 minus ln x square plus 3. Now if you further simplify, you will get it here. This is equal ln x plus 3. This will be ln sine x plus 2 plus e to the power ln e to the power 3x will be 3x minus 3 ln x plus 5, and the last one is ln x square plus 3 as it is. Now we'll apply the derivative. So d dx of ln y is equal, this one will be 1 over x plus 3 plus 1 over sine x plus 2, and then derivative of sine x plus 2. 3x derivative will be 3 minus 3 ln x plus 5 will be x plus 5 and minus 1 over x square plus 3 d dx of x square plus 3. So this is equal 1 over y ln y is equal 1 over x plus 3 plus sine x plus 2 will be cosine x plus 2 over sine x plus 2 plus 3 minus 3 over x plus 5 minus 2x over x square plus 3. So this implies so this one is 1 over y dy dx. So this implies dy dx is equal y, you will write whole terms 1 over x plus 3 plus cot x plus 2 minus 3 plus plus 3 minus 3 over x plus 5 minus 2x x square plus 3. We can simplify further, but we can keep it also like this, and we can mention here y is, here substitute the y as given here. Simplify as per requirement. Our next problem is y equal tan x over x sine 2x. Derivative can also be solved by the cosine rule, but here we will solve it by the by applying the logarithm function. So apply ln on both sides. Y is equal ln tan x over x sine 2x. So this will gives you ln tan x minus ln x minus ln sine 2x. Then by taking the derivative we will have here 1 over y dy dx, which is equal ln derivative is 1 over tan x, then derivative of tan x minus 1 over x minus 1 over sine 2x derivative of sine 2x. So this is equal derivative of tan, so dy dx is equal dy dx is equal y tan x derivative is secant square x tan x minus 1 over x and sine 2x, it will be 2 cosine 2x, so minus 2 cosine 2x over sine 2x. So this is equal tan x over x sine 2x secant square x tan x minus 1 over x minus 2 cosine 2x over sine 2x.